February 2nd, 1943. "3,000 feet over the frozen farmland of occupied Holland, a British four-engine bomber is falling out of the sky. It's a short Sterling, a Pathfinder, the squadron that flies in first, before everyone else, to mark the target in the dark. Inside the fuselage, in the freezing cold, sits a metal box about the size of a small suitcase. That box is the single most closely guarded secret in the entire Royal Air Force. The crew know exactly what's inside it. They know they're not supposed to be carrying it over enemy territory at all. And they know that if the aircraft goes down, that box is supposed to be destroyed, burned, blown apart, reduced to slag, so no German hand ever touches it intact. The aircraft crashes near a small Dutch town. Most of the crew die, and the box does not burn. You'd assume that's the end of the story. Secret lost, advantage gone. The war becomes fair again. It isn't. For the next 2 years, some of the finest radar engineers in the world held that exact machine in their hands. They studied it. They photographed it. They built an entire committee around it. And they still couldn't catch up, not in the skies over Germany, not in the Atlantic, not anywhere it mattered before the war ended. To understand what those German engineers were holding, you need to understand a decision made 19 days before the crash. German radar in 1942 wasn't primitive. It was, in many respects, excellent, a gun-laying system called Würzburg, accurate and mass-produced, and an early warning network called Freya that could see Allied bombers forming up over England before they'd even crossed the coast. This was a mature, confident, world-leading program, and the men running it had every reason to trust their own judgment. Their judgment told them something specific, that useful radar simply could not be generated at very short wavelengths, what's called the centimetric band, anything under 10 centimeters. Every attempt anyone had made to build high power at that wavelength had failed. The physics, as they understood it, set a hard ceiling. This wasn't an unreasonable belief. It was the considered conclusion of serious scientists looking at every available data point. Given finite wartime resources and a pressing front, pouring effort into a band everyone agreed was a dead end would have looked like negligence, not caution. At the end of November 1942, German industry made what seemed like an entirely rational call. They closed the centimetric research laboratories. On January 15, 1943, the German Air Ministry confirmed the decision as final. The Sterling went down 19 days later. The technicians who opened that box in the Dutch mud weren't just examining an enemy radar set. They were holding the working proof that the decision they'd finalized 19 days earlier was the single greatest technical misjudgment of their war. The device in the box was called H2S, an airborne radar that did something nobody had done before. It looked downward, through total darkness, through cloud cover, and painted the ground below onto a screen. Coastlines, rivers, cities. A navigator deep inside enemy territory in pitch darkness could see the terrain beneath him as though reading a map lit from within. But the truly important thing wasn't the radar itself. It was the single component that made it possible, a small, heavy block of copper called the cavity magnetron. It was built in February 1940 at the University of Birmingham by two physicists named John Randall and Harry Boot, sealed with wax and connected to a vacuum pump in a university lab. Their experimental device produced 400 watts at just under 10 centimeters, roughly 100 times more power at that wavelength than anything that had previously existed. The exact thing the German establishment would later declare impossible, sitting on a workbench, built with improvised parts, by a small team nobody had heard of. The American official historian who later received one of these devices in Washington called it, without exaggeration, the most valuable cargo ever delivered to American shores. Short wavelengths meant small antennas, which meant the radar could fly in an aircraft. Short wavelengths meant fine resolution, which meant you could pick a submarine's conning tower out of open ocean or paint city streets onto a screen from miles up. Everything the Allies were about to do in the air and at sea over the next 2 years flowed from that one piece of machined copper. That's what was in the box. That's what didn't burn. British bombers carrying H2S were fitted with a demolition charge specifically because of the magnetron's design. A glass radio valve shatters on impact and tells the enemy almost nothing useful. But the magnetron was a solid block of machined copper, and the entire secret of how it worked could be read straight from the shape of the cavities inside it. Copper doesn't shatter. Copper survives. There had been a serious argument at the top of the British war effort about whether to fly the device over enemy territory at all. A safer, less revealing component existed, but it produced 20 to 30 times less power, and a radar built around it would have been nearly useless. Churchill personally released the magnetron for operations and ordered the sets built as fast as possible. That was the bet. Britain's most advanced technology, flown directly over enemy soil, because the war planners calculated that the advantage it gave them now outweighed the cost of eventually losing the secret. The captain of that Sterling, Squadron Leader William Arthur Smith, held the Distinguished Flying Cross. He and most of his crew died that night, on only the second operational flight the device had ever flown. Pathfinders flew the most dangerous missions in Bomber Command, going in first, alone, ahead of everyone else. This is exactly the kind of story this channel exists for, not just what happened, but why the obvious explanation everyone assumes is usually wrong. If you want more of this, subscribe to WW2 Forgotten Frontlines now. We're just getting to the part that actually answers the question we opened with. Here's where most retellings of this story go wrong, and where the real answer lives. The Germans understood what they had almost immediately. They weren't slow. They named the captured device the Rotterdam Gerät, after the city near where it was found, and formed a dedicated working group of their best radar minds, the Rotterdam Arbeitsgemeinschaft, which held its first meeting on February 23rd, just 3 weeks after the crash, at Telefunken's offices in Berlin. Think about what that represented. 8 weeks earlier, German radar physics had declared centimetric radar a dead end and shut the labs. Now the most senior people in the field were sitting in Berlin, with proof they'd been wrong, scrambling to undo their own decision. They had the device, they had the brains, they had the committee, and they still lost the race. Understanding the magnetron took the Germans almost no time. Building it by the thousands, to a reliable standard, fitted into aircraft and ships across an entire military, was a completely different problem. It wasn't a scientific question, it was an industrial one. British analysts, when they first realized a set had been lost, made a cold prediction. It would take Germany roughly 2 years to field its own centimetric radar in any numbers. That estimate turned out to be almost exactly right, and by 1943, with the war turning month by month against Germany, 2 years was time they simply didn't have. There was also the matter of materials. Manufacturing a magnetron to scale required precision machining, stable high-grade magnets, and reliable crystal detectors sensitive enough to catch a faint radar echo and rugged enough to survive in service. Britain and America, between them, had the industrial base and the supply lines to produce these by the tens of thousands. Germany blockaded, and increasingly under bombardment did not. A design copied in an afternoon is not a factory. The Germans could replicate the idea instantly. They could not replicate the production line. And there's a brutal symmetry in the third reason. The same Allied bombing campaign that H-2S itself was built to guide was simultaneously destroying the German factories and laboratories that would have had to build the German answer to it. A second captured H-2S set, recovered weeks later, was destroyed in the same raid that damaged the Telefunken facility studying the first one. The race and the bombing were the same event. The same magnetron, pointed not at the ground but at the sea, became the deciding weapon of the Battle of the Atlantic. British radar saw the ocean at roughly 9 centimeters. German submarine warning receivers, called METOX, were tuned to listen for radar around 1.5 meters. 9 centimeters versus 1.5 meters. That single gap is the whole difference between hunter and hunted in 1943. A U-boat surfacing at night to charge its batteries watched its warning receiver register nothing, and an aircraft would appear out of total darkness with no warning at all, because the equipment they trusted simply could not hear the frequency hunting them. In May 1943 alone, Germany lost 41 U-boats, roughly a quarter of its operational fleet, in a single month. Admiral Karl Dönitz withdrew his submarines from the North Atlantic on May 24th. The convoys kept coming. The war's industrial lifeline held. That story, in full, belongs to a different video. What matters here is this. It was the same captured magnetron, sitting on the same Berlin workbench, that finally gave German engineers the explanation for losses they couldn't otherwise account for. Understanding the cause and building the cure remained two entirely separate problems. Telefunken did eventually build a working centimetric airborne radar, a direct copy of the British design. It entered service in April 1945. The war in Europe ended in May. Perhaps 10 sets ever became operational. The British had been flying thousands for 2 years. The Germans crossed the finish line as the stadium was being dismantled around them. I want to be honest about the limits of this story, because the truth holds up better than the legend. The magnetron wasn't conjured from nothing by two lone geniuses working in isolation. Centimetric radar had been pursued in various forms in several countries, before Birmingham in America, in the Soviet Union, in Japan. The German physicists who opened that box even recognized elements of the underlying principle from earlier published Russian research. What Randall and Boot actually achieved wasn't the bare idea. It was the high-power, manufacturable, war-winning version of it built, then produced by the tens of thousands, then flown over enemy territory, with full knowledge of what losing it might cost. There are also genuine uncertainties in the record. Historians still disagree on which German night fighter pilot actually brought the Sterling down. The U-boat losses for Black May are recorded variously as 41 or 43, depending on how different accounts count across theaters. Real history has seams like this. Legends usually don't. But the core of it holds. A Pathfinder Sterling went down near Rotterdam on the night of February 2, 1943. The Germans recovered its magnetron intact. 19 days earlier, they had declared the very thing they now held in their hands to be impossible. And despite holding the answer, in a country running short of metal, time, and intact factories, they could not close a gap their enemy had deliberately bet they couldn't close. That's the actual verdict. Not that German scientists were foolish, they weren't. They were beaten by a decision made 8 weeks too early, and by the kind of country each side had built behind its laboratories. The British understood that the cleverest machine in the world is worth nothing if the other side can build it faster than you can use it against them. They were right, and they knew it before they ever loaded that box onto the aircraft. If this changed how you think about what actually wins a technology race, subscribe to WW2 Forgotten Frontlines. We dig into the decisions behind the headlines, the ones made in committee rooms and ministry offices, that decided outcomes years before anyone fired a shot.